NASA's Europa Clipper radar passes key tests during Mars flyby. We just peeked under Mars' red veil, and the radar didn't blink. That single electrifying moment earlier this year told NASA that its Europa Clipper spacecraft is ready for the real prize, cracking open the secrets hidden beneath Europa's frozen shell. But here's where it gets controversial. Some scientists argue that even if Clipper finds an ocean teeming with organic chemistry, we still won't know whether life is actually swimming down there. Ready to dive into the debate? On March 1st, Clipper streaked past the rusty deserts of Mars at a razor-close 550 miles, 884 kilometers, using the planet's gravity like a cosmic slingshot to bend its trajectory toward Jupiter. While the maneuver saved precious fuel, it also served as the ultimate pop quiz for the probe's star instrument, Reason. Radar for Europa assessment and sounding, ocean to near surface. Over a tense 40-minute window, the radar fired radio waves at the volcanic plains below, then listened for faint echoes bouncing back from ancient lava flows. The result? Roughly 60 gigabytes of pristine data, enough to fill a high-end laptop, arrived without a hitch, according to NASA's euphoric press release. Think of Reason as a planetary ultrasound. Just as doctors send sound waves through skin to image a baby, Reason transmits low-frequency radio waves through Europa's multi-mile ice crust. When those waves hit a boundary, say a pocket of briny water or a slushy layer, they reflect back, painting a cross-sectional picture of what lies beneath. The catch: the antennas needed to pull off this feat stretch 58 feet, 17.6 meters tip to tip, rivaling the wingspan of a small aircraft. They're bolted to solar arrays the size of a basketball court, because sunlight at Europa is a feeble 1/25th as bright as on Earth. Imagine trying to power your house with a single Christmas bulb. That's the challenge Clipper's solar wings are designed to overcome. Back on Earth, engineers had already tested Reason on hilltops above NASA's Jet Propulsion Laboratory. But those trials were partial at best. A full-scale echo test would have demanded a sterile chamber longer than a football field, an impossible ask when every component had to remain pristine for launch. That made the Mars flyby the first true dress rehearsal in deep space, and the entire team held its breath. "We got everything out of the flyby that we dreamed," said Don Blankenship, the University of Texas geophysicist who leads the Reason team. Translation: every circuit, every antenna, every line of code behaved exactly as designed. Deputy Science Manager Trina Ray described the scene at Mission Control as pure elation, with scientists shouting, "Oh, look at this! Oh, look at that!" as waveforms scrolled across their screens. Launched in October 2024, Europa Clipper is now gliding across 1.8 billion miles, 2.9 billion kilometers of black ocean. Currently 280 million miles, 450 million kilometers from home, it will swing back for an Earth gravity assist in December 2026, before finally reaching the Jupiter system in 2030. Once there, it will execute 40 daring flybys of Europa, skimming as low as 16 miles, 25 kilometers above the surface. Each pass will peel back another layer of the moon's icy armor, hunting for the chemical fingerprints of life. Salts, organics, even plumes of water vapor venting into space. And this is the part most people miss. Finding liquid water doesn't automatically mean finding life. Europa's ocean could be sterile, or it could host microbes unlike anything Earth has ever seen. Some astrobiologists argue that Clipper's radar might detect a perfect habitat, yet still leave us debating for decades whether biology ever moved in. Others counter that any sign of complex organics, especially if they're chirally biased like Earth's amino acids, would be a smoking gun. Which side are you on? So, as Europa Clipper sails deeper into the dark, one question lingers: if the radar reveals a warm, salty ocean rich in the ingredients for life, should humanity push immediately for a lander, or wait until we can send a cryobot to melt straight through the ice? Drop your take in the comments. Bold exploration now, or cautious reconnaissance first. NASA's Europa Clipper radar breakthrough on Mars flyby. NASA's latest radar technology has achieved a remarkable feat that many thought was impossible on Earth. In a groundbreaking event during a close flyby of Mars, NASA's Europa Clipper spacecraft successfully tested its radar system, known as Reason, for the very first time in the vastness of space. The flawless operation of this radar system has left scientists exhilarated as it effectively bounced signals off the Martian surface. This accomplishment not only demonstrates the radar's readiness to explore Europa's icy shell for potential signs of a concealed ocean, but also resulted in the collection of 60 gigabytes of data. This data not only confirmed the reliability of the hardware, but also provided researchers with an invaluable opportunity to refine their analytical tools ahead of the Clipper's anticipated arrival at Jupiter's icy moon in 2030. Success of the Mars flyby radar test. In March, as the Europa Clipper spacecraft made its way past Mars, it conducted a vital radar test that could not have been executed on Earth. After thoroughly analyzing the complete dataset, mission scientists were pleased to announce that the test was a resounding success. The radar system functioned precisely as intended, transmitting and receiving signals from the vicinity of Mars's equator without encountering any problems. The radar, aptly named Reason, Radar for Europa Assessment and Sounding, Ocean to Near Surface, is specifically designed to penetrate beneath the surface of Europa, which is Jupiter's fourth largest moon. Scientists are optimistic that it will uncover pockets of water trapped within the moon's thick ice shell and may even identify the expansive ocean believed to exist beneath it. Reason: investigating Europa's icy shell. We achieved everything we hoped for from the flyby, expressed Don Blankenship, the principal investigator of the radar instrument at the University of Texas at Austin. The primary objective was to assess the radar's readiness for the Europa mission, and it performed flawlessly. Every component of the instrument demonstrated its capability to fulfill our expectations. The data collected from the radar will assist researchers in exploring how materials from Europa's subsurface ocean might ascend through the ice and reach the surface. Additionally, it will enable scientists to analyze surface features, such as ridges, and investigate how these features connect with structures detected beneath the ice. Limitations of Earth-based testing. The Europa Clipper features a unique radar configuration for an interplanetary spacecraft. Reason employs two pairs of slender antennas that extend from the solar arrays, covering a span of approximately 58 feet, 17.6 meters. These solar arrays are massive, comparable in size to a basketball court, allowing them to capture as much sunlight as possible at Europa, which receives only about 1/25 of the sunlight that Earth does. Prior to the spacecraft's launch from NASA's Kennedy Space Center in Florida on October 14, 2024, the instrument team conducted all feasible testing. During the development phase, engineers at the Jet Propulsion Laboratory, JPL, in Southern California even took their work outdoors, utilizing open-air towers on a plateau above JPL to stretch and test engineering models of the instrument's delicate high-frequency and compact very high-frequency antennas. However, once the actual flight hardware was constructed, it had to be kept sterile and could only be tested in a controlled environment. Engineers utilized the expansive High Bay 1 clean room at JPL, where the spacecraft was assembled, to test the instrument piece by piece. To evaluate the echo or the return of Reason signals, they would have required a chamber approximately 250 feet, 76 meters, long, nearly 3/4 the length of a football field. Mars Gravity Assist and Data Bonanza. The primary objective of the mission during the Mars flyby on March 1st, less than 5 months after launch, was to harness the planet's gravitational force to alter the spacecraft's trajectory. However, this flyby also provided opportunities to calibrate the spacecraft's infrared camera and conduct a dry run of the radar instrument over terrain that NASA scientists have been studying for decades. As the Europa Clipper sped past the volcanic plains of the Red Planet, descending from 3,100 miles, 5,000 kilometers, to just 550 miles, 884 kilometers above the surface. Reason transmitted and received radio waves for approximately 40 minutes. In contrast, at Europa, the instrument will operate as close as 16 miles, 25 kilometers, from the Moon's surface. This animation illustrates a 360 degrees view of NASA's Europa Clipper spacecraft and highlights its scientific instruments. Reason delivers 60 gigabytes of valuable data in total. Engineers successfully gathered 60 gigabytes of rich data from the instrument. Almost immediately, they recognized that Reason was functioning optimally. The flight team scheduled the complete dataset for download, commencing in mid-May. Over the following months, scientists eagerly examined the information in detail and shared insights. The engineers were thrilled that their test was executed so flawlessly, remarked Trina Ray, Europa Clipper's deputy science manager at JPL. Everyone who had dedicated so much effort to make this test a reality, along with the scientists witnessing the data for the first time, was overjoyed, exclaiming, "Oh, look at this! Oh, look at that!" The science team is getting a head start on learning how to process the data and comprehend the instrument's behavior in relation to models. They are honing their skills just as they will need to when they reach Europa. The total journey for Europa Clipper to reach the icy Moon will span approximately 1.8 billion miles, 2.9 billion kilometers, and will include one more gravity assist, utilizing Earth in 2026. Currently, the spacecraft is about 280 million miles, 450 million kilometers, away from Earth. More about Europa Clipper. Europa Clipper represents NASA's ambitious mission to investigate Jupiter's icy moon Europa, which is considered one of the most promising locations in our solar system for the search for signs of life. Scheduled to arrive in the early 2030s, the spacecraft will conduct nearly 50 flybys of Europa, employing a powerful array of instruments to explore the Moon's ice shell, subsurface ocean, composition, and surface geology. The mission has three primary scientific objectives. 1. Measure the thickness of Europa's ice shell and evaluate how it interacts with the ocean beneath. 2. Analyze the Moon's composition, searching for organic materials, salts, and other essential ingredients for life. 3. Characterize surface features and geology, aiding scientists in understanding the Moon's dynamic history. By conducting a comprehensive survey of Europa, this mission will help assess the habitability of this ocean world and broaden our understanding of potentially life-supporting environments beyond Earth. Led by NASA's Jet Propulsion Laboratory, JPL, in Southern California, and managed by Caltech for NASA, Europa Clipper involves key partnerships with the Johns Hopkins Applied Physics Laboratory, APL, which designed the spacecraft body, along with NASA's Goddard, Marshall, and Langley centers. The radar instrument Reason is spearheaded by the University of Texas at Austin, and the spacecraft was launched under the guidance of NASA's Launch Services Program at Kennedy Space Center. This nationwide collaboration is paving the way for one of the most thrilling planetary science missions of the decade. Stay updated on groundbreaking discoveries. Subscribe to the SciTech Daily newsletter. WhatsApp's surprising new Guest Chats feature explained. Imagine being able to chat with someone on WhatsApp, even if they don't have an account. Sounds revolutionary, right? But here's where it gets controversial. WhatsApp's upcoming Guest Chats feature, while promising, comes with some surprising limitations that could spark debate among users and tech enthusiasts alike. WhatsApp is currently working on a new feature called Guest Chats, designed to let people communicate with others who haven't signed up for WhatsApp. The way it works is simple yet innovative. Users will be able to send a direct link to anyone, and the recipient can join the chat through that link. No app installation required. This could be a game changer for those who are hesitant to download yet another messaging app, or for quick, one-off conversations. But, and this is the part most people miss, guest chats are strictly limited to one-on-one conversations. Group chats are off the table, at least for now. This is a significant restriction, especially considering how popular group messaging has become for both personal and professional communication. According to WAD Beta Info, this feature is still in the development phase and hasn't even reached beta testers yet. Early reports suggest that guests will access these chats via WhatsApp Web, leveraging the platform.